Good afternoon everyone. I am Janus Christian Ifermiza and today we will discuss the automatic sprinkler and other extinguishing equipment. This will be the content of my report. First is the automatic sprinklers and other extinguishing equipment. Second is the standpipes. First is the automatic sprinkler. Let's talk about automatic sprinkler. An automatic sprinkler is a fire suppression or fire control device with a heat-activated element. The sprinkler operates automatically when the air temperature rises to or above the device specified temperature rating. When that happens, the sprinkler discharges water over a specified area. Kaning automatic sprinkler is common siya sa mga buildings, no, like malls and schools. Automatic sprinkler is really efficient on preventing fire from spreading, no, since basahon man niya ang area. Next is standpipe. Standpipe is a type of rigid water piping which is built into multi-story buildings in a vertical position or into bridges in a horizontal position to which fire hoses can be connected, allowing manual application of water to the fire. Within the context of a building or bridge, a standpipe serves the same purpose as fire hydrant. Next is automatic sprinklers and other extinguishing equipment. In general, automatic sprinklers, if required by Division 8 through Division 17 of this chapter, shall be in accordance with NFPA 13 standard for the installation of sprinkler system. All automatic sprinkler and standpipe systems required by this code shall be inspected, tested, and maintained in accordance with NFPA 25. Standard for the inspection, testing, and maintenance of water-based fire protection systems. Records of conducted maintenance and testing should be maintained and submitted together with FALAR 3. Where a required automatic sprinkler system is out of service for more than 4 hours in a 24-hour period, the owner shall notify the nearest station immediately upon discovery but not later than 24 hours, and a fire watch shall be assigned until the sprinkler system has been returned to service. Sprinkler impairment procedures shall comply with NFPA 25 standard for the inspection, testing, and maintenance of water-based fire protection systems. Next is supervision. Supervisory signals, where supervised automatic sprinkler systems are required by another section of this code. Supervisory attachments shall be installed and monitored for integrity in accordance with NFPA 72. Alarm signal transmission, where supervision of automatic sprinkler system is required, water flow alarm shall be transmitted to an approved proprietary alarm receiving facility, a remote station, a central station, or the fire station. Next is the other automatic extinguishing equipment. In any occupancy where the character of the potential fuel fire is such that extinguishment or control of fire will be more effectively accomplished by a type of automatic extinguishing systems other than automatic sprinkler systems, such as but not limited to carbon dioxide, dry chemical, foam, or water spray. A standard extinguishing system of appropriate type shall be installed subject to the approval of the city or municipal fire marshal having jurisdiction. If the extinguishing system is installed in lieu of a required supervised automatic sprinkler system, the activation of the extinguishing system shall activate the building fire alarm system where provided. The activation of an extinguishing system that is not installed in lieu of required supervised automatic sprinkler system shall be indicated at the building fire alarm system where provided. Manual extinguishing equipment. Any fire extinguisher provided shall be installed, inspected, and maintained in accordance with Section 10.2.6.7 of this IRR. Each standpipe and hose system provided shall be in accordance with Section 10.2.6 of this IRR. Next is standpipes. The design, installation, and maintenance of standpipe systems shall be in accordance with NFPA 14, standard for the installation of standpipe, private hydrant, and hose systems. Which is classes of standpipe system. A standpipe system shall be any of the following. First is the Class 1 system. This system is provided with 64 mm or 2/2 inch hose connections for full-scale firefighting at the following designated building locations. First is the at each intermediate landing between floor levels in every required exit stairway. Second, on each side of the wall adjacent to the exit openings of horizontal exits. Third is niche exit passageway at the entrance from the building areas into the passageway. Fourth, in covered mall buildings at the entrance to each exit passageway or exit corridor, and at exterior public entrances to the mall. Fifth, at the highest landing of stairways with stairway access to a roof, and on the roof where stairway do not access the roof. An additional 64 mm or 2/2 inch hose connection shall be provided at the hydraulically most remote riser to facilitate testing of the system. So sixth, where the most remote portion of a non-sprinklered floor or story is located in excess of 40 meters of travel distance from a required exit containing or adjacent to a hose connection, or the most remote portion of a sprinklered floor or story is located in excess of 61 meters of travel distance from a required exit containing or adjacent to a hose connection. Next is the Class 2 system. This is a hose connection provided with 38 or 1/2 inch hose or within the 37 meters of a hose connection system shall be provided with 38 millimeters hose connection for first aid firefighting, so that all portions of each floor level of the building are within 40 meters of provided with less 38 mm hose. Distances shall be measured along a path of travel originating at the hose connection. So, Class 3 system. This system shall be provided with hose connection as required for both Class 1 and Class 2 system. So, in summary, Class 1 system features 2.5 inch hose connections that can only be accessed by firefighters during an emergency. So their outlets are usually located within the stairwells of buildings, and they are restricted to use by professional firefighters because the system's high power pressure makes controlling the hose difficult, and as a result, firefighters must bring a hose to the site that specifically attaches to the connections. For the Class 2 system, it features permanently installed hoses on pin racks or reels that can be accessed by anyone in the event of a fire. They feature 1.5 inch hose connections and are often located in hallways of buildings. Because hoses are sometimes poorly maintained in and building owners are concerned about liability of if an untrained individual gets hurt trying to fight a fire. These systems have fallen out of favor and are typically present in older buildings. Next is the Class 3 system. A hybrid of Class 1 and Class 2 systems, featuring both 2.5 inch and 1.5 inch hose connections with permanently available hoses attached to the 1.5 connections. The first Class 3 system had a 2.5 inch connection with a reducer that allowed an installed hose to be attached to a 1.5 inch connection. Firefighters removed the reducer to attach larger hoses. Some later versions feature both a 2.5 inch firefighter connection in addition to a separate 1.5 inches connection attached to an on-site installed hose. Finally, there are versions of Class 3 systems that features a 2.5 connection, a reducer to 1.5 connection, and no installed host. So that is for the summary of the classes of standpipe system. So next is the dry standpipes. Dry standpipe shall be used for Class 1 system. All buildings with required enclosed stairway or smoke-proof enclosure shall have at least one dry standpipe outlet connection located at every floor level, landing above the first floor of every required enclosure. No point within a building requiring dry standpipes shall be more than 40 meters travel distance from a dry standpoint outlet connection. Dry standpipes shall not be concealed in building walls or built into pilasters. Portion of dry standpipe system not located within an enclosed stairway or smoke-proof enclosure shall be protected by a degree of fire resistance equal to that required for vertical enclosures in the building in which they are located. So detailed requirements for installation of dry standpipes. First is the construction. Fitting and connections shall be of sufficient strength to withstand 300 psi of water pressure when ready for service. All dry standpipes shall be tested hydrostatically to withstand not less than 50 psi above the maximum working pressure. Next is piping. All horizontal runs of dry standpipe system shall have a 20% slope of the purpose of draining. Where pipe traps occur in such standpipe systems, including fire service connections, they shall be provided with drains. So next is size. The size of the standpipe shall have a diameter of at least 102 millimeters in buildings in which the highest outlet is 23 meters or less above the fire service connections and shall not be less than 153 millimeters where the highest outlet is higher than 23 meters above the fire service connection. So for more information about the detailed requirements for installation of dry standpipe, you can refer on the Fire Code of the Philippines, page 102 to 103. Next is wet standpipes. So wet standpipe system extending from the cellar or basement into the topmost story shall be required in the following. First is the assembly occupancies with an occupant load exceeding 1,000. Second is educational, healthcare, and detention and correctional, business and mercantile, industrial, and hotels and apartments occupancies, 4 or more stories in height. Next is hazardous storage and business and mercantile occupancies having a floor area exceeding 1,816 square meters per floor. However, the preceding provision does not apply to buildings equipped throughout with an approved supervised sprinkler system, basement or cellars equipped with approved supervised sprinkler system. Location. Wet standpipes shall be located so that all portions of the buildings within 6 meters of a nozzle attached to 22 meters of hose. In theaters, auditoriums, and other assembly occupancies where the occupant load is more than 1,000, outlets shall be located on each side of any stage, on each side of the rear of the auditorium, and on each side of the balcony. So, detailed requirements. Construction. Wet standpipe shall be installed and tested as required for the water distribution system within the building. Size. The size of the standpipe shall not be less than 64 mm in diameter. Outlets. All interior wet standpipes shall be equipped with 38 mm valve in each story, including the basement or cell roof of the building, and located not less than 91 cm nor more than 182 cm above the floor. Water supply. The wet standpipe shall deliver not less than 132 liters of water per minute at not less than 101 and 8 kilos per square centimeters residual pressures from each of any two outlets flowing simultaneously for 30 minutes. So pressure and gravity tanks. Pressure or gravity tank shall have a capacity sufficient to furnish at least 265 liters of water per minute for 30 minutes. Other such tanks shall be located so as to provide not less than 1 and 8 kilos per square centimeters residual pressure from each of two outlets flowing simultaneously for 30 minutes. Discharge pipes from pressure tank shall extend 5 centimeters from and into the bottom of such tanks. All tanks shall be equipped with a manhole, ladder, and a platform, drain pipe, water pressure gauges, and a pressure relief valve. Pressure reduction. Where the static pressure at any standpipe outlet exceeds 7 kilos per square centimeter, an approved pressure reduction device shall be permanently installed at the outlet to reduce the water flow so that the nozzle pressure does not exceed 5 and 6 kilos per square centimeters in accordance with Table 7.